Okay, birthday problem. This is actually pretty interesting. Excuse me. And when you're at a party or over at some friend's house, you can actually do this. It's really, with people you don't know, it's actually kind of interesting. Because basically, what happens is if you're in a room full of people, there is a pretty high chance that at least two people are going to have a share a birthday, which doesn't seem like that should happen, but it really is pretty high. So we've got this. What's the probability that if you've got in a room with 10 people having 10 different birthdays, or 10 people in a room, what's the probability that they all have 10 different birthdays? So, A, 10 people, what's the probability that all 10 have 10 different birthdays? Okay. Well, if we go back to the basic definition of probability on this one, the probability that all 10 have 10 different birthdays. Well, how many different ways, on the number on the bottom, this is the number of ways people can have birthdays. Number of ways, number of days. And this is number of ways people can share or can have different birthdays. Does that make sense? So it's the total number of ways people can have birthdays on the denominator, and then on the numerators, how many ways can they have a different birthday? Kind of like how many different ways can you drive in a particular path across the country, and so forth. So how many different ways can people have, how many ways can people have birthdays? Well, if there's 10 of them, the first one has 365 different days they could have their birthday. The second one can have 365 days they could have their birthday. The third one, 365, all the way out to 365, and there's 10 of them. Now, if they have different birthdays, how many choices does the first person have? 365. How many choices does the second person have to have a different birthday? 364. The third one, 363, and so forth, all the way down to 356. Okay. This guarantees that they have, or this is the number of ways they can all have a different birthday. So if you do this, you get crazy big numbers, but you end up with 0.883, or 88.3%. Okay. Right. And B, okay, so there's an 88% chance that all 10 have different birthdays. What's the complement of this, of all 10 have 10 different birthdays? Of A, or question mark? The complement of part A is the probability that if all 10 have different birthdays, the complement is at least 2 share a birthday. And what is the probability of at least 2 share a birthday? 1 minus the probability that all are different, which is 1 minus 0.883, which is 11.7%, which is actually a pretty big percent for that. So if you have a group of 10 people, there's an 11.7% chance of sharing a birthday. All right, there's the birthday problem. 36, party affiliation. We've got parties and age group. Are the events Republican and 30 to 34 independent? Well, I would look at this. What's the probability that you are a Republican? And what's the probability that you're a Republican given your 30 to 44? So probability you're a Republican is 2,200 out of 4,000. Given your 30 to 44, 724. What's probably your Republican now? 340. And let's compare those two. Okay. So the top one is, I'm going to get rid of those zeros, is 22 over 40. It's 55%. And 340 divided by 724 is 47%. And so if you're in this group, what it says is there's a smaller percentage of people that are Republicans compared to overall. So they are not independent. So there's A. B. Democrat and over 65. Democrat given greater than 65. So probably your Democrat is 1,800 over 4,000. Greater than 65, given you're greater than 65, and a Democrat, 459. So 1,800 divided by 4,000 is 45%, and 459 divided by 1020 is 45%. So it looks like being over 65 does not affect whether you're a Democrat or not. So we can say they're independent. C. 17 to 29 and 45 to 64, are they mutually exclusive? Can you be in both of those age groups? And the answer is no, you can't. B. So yes, they are mutually exclusive. Okay, you can't be both 17 to 29 and 45 to 64. Although these guys probably wish they could go back and so forth. Well, maybe not. D. So yes. Are the events Republican and 45 to 64 mutually exclusive? And the answer is no, because those 1075 people say they're not. Those 1075 people are both Republicans and 45 to 64, so there's definitely some overlap. Republicans, 45 to 64. There's a bunch of people that are in between, or that are in both. All right, there we go.